Hello everyone. This video is on Knewton Alta assignment, section 2.2, part 1, called Solve Linear Equations in One Variable. So in this video, I'm going to be going over a version of this Knewton Alta assignment. Please understand that the questions I see in this video may not be exactly the same questions you see when you work on the assignment yourself. But the objectives are the same, and they should have similar questions. So I'm hoping that watching me do these examples here help you in some way when you're working on the assignment yourself. Alright, so here's the assignment page. You will not see the words preview of, you'll just see the title. You got your mastery bar telling you how far along you've gotten. The objectives, it looks like there are 3 objectives in this assignment. And under the current objective is a question related to that objective. And at the bottom of the question, every question, you should see a few buttons. There's the feedback button. This is if you see a typo or something wrong with the question or the answer, something doesn't make sense, something isn't clear or totally wrong. Send feedback to Knewton, and hopefully they'll address you and fix the mistakes. You will not see this instructor cheat button, right? This is for instructors only, for me only. You will see the more instruction button, which is very useful. If you're in an objective that you don't know about, or something's unclear to you, or you're struggling with a question, don't just guess and get it wrong, because if you get things wrong, the progress bar will go backwards, and you'll just have to do more questions correctly to finish the assignment. So if you're struggling, click on more instruction, and it'll take you to some reading or maybe some videos or both related to that particular objective, and then you'll see some questions related to that instruction, and hopefully those will be easier to do if you have the instruction in front of you. And you can, for every single new question, go to more instruction and get through the assignment that way. Alright, it just might take a little longer, that's all. But still, you can do that. Alright, so let's get into it. Now the first question here is on the objective, solve equations in one variable, algebraically, variable just on one side. Alright, so we're asked to solve the following equation for x, and report your answer as a fraction. Alright. So when they say solve an equation, that just means you're trying to find the values, the numbers you can replace the variable with to make a statement true. Right, to make the left side here equal to the right side, make them be the same number. Alright, so let me write this out. So this first equation we're given is 9 times x divided by 4, right, or 9/4 times x, same thing, plus 5/2, right, 5/2, equals -1/2. Alright. Now I'll show you a couple ways to do this particular equation, because this is an equation with fractions. Very often people have a hard time dealing with fractions. Now you can leave the fractions the way they are. The first step is to get all the terms with the variable on one side, which it already is. So get all terms with the variable to one side, which again, this 9x over 4, this 9/4 times x, this is the only term with a variable. It's already on the left. It's already on one side, and then there's no other terms of the variable. So that part's done. And get all the terms without the variable to the other side. Alright, so I've got the 9/4 x on the left. So this positive 5/2 I don't want. So what you do is you do addition. To do this, you do addition and subtraction. And what you do, just remember that what you do to one side of an equation, you must do to the other side to keep it balanced. So here's our original left side. I'm going to leave a little space here, equals -1/2. The reason I left some space is because what I want to do is I want to get rid of this positive 5/2 by subtracting it. I'm subtracting 5/2 from, and do it to both sides. Right. So that makes 0 here, and all I'm left with now is 9x divided by 4. 9/4 times x equals. Now, when you add or subtract numbers, they need the same denominator, which both of these do. And remember, when you add and subtract numbers with the same denominator, that denominator stays. So still a denominator of 2. You just combine the numerators, which are -1 and -5. So -1 plus -5, or -1 minus 5. So this on the right side here, -1/2 minus 5/2 is -6/2. -6 divided by 3. But that simplifies to just -2. Alright? Alright, so I get all the terms with variables on one side, terms without the variable on the other side, and you simplify as you go, like I did here, right? -2. Then you're going to multiply or divide to get the variable alone. Multiply. I'll say multiply / divide. You might do either one because they're really related, right? Division is just multiplication by the reciprocal. To get the coefficient of the variable to be 1. Now, coefficient is just a fancy word for the number attached to the variable. Like right now, the number attached to the variable is 9/4. I want it to be 1. So to get the coefficient of the variable to be 1, right, the number 1. Alright, so again, I got my, here's the equation right now. And to get the you can divide by the number, right? Any number divided by itself. 9/4 divided by 9/4 is 1. But dividing is also multiplying by the reciprocal, right? So instead of dividing by 9/4, because that looks kind of ugly, dividing by fractions, I'm going to multiply by 4/9, right? That's the reciprocal of 9/4. That way the 9's will cancel, the 4's will cancel, and I'll be left with just 1x. And I do the same thing to the other side, right? Times 4/9. So over here, 9's cancel, 4's cancel, I'm left with just x equals. And -2 you can think of as -2/1. Now when you multiply, you don't need the same denominator. Alright, when you add or subtract like I did earlier, you need the same denominator. Alright. When you multiply, you just multiply the numerators, multiply the denominators. You might have to simplify. You might have to cancel out some common factors in the numerator and denominator, but it's very simple. It's -2 times 4 for the numerator, -8. And then 1 times 9, 9 in the denominator, and there you go. X is alone. We have the solution. X equals -8/9. Now, I'm not going to do this for every single problem because it takes some time, but you should be doing this. Check your solutions. Make sure that when you go back to the original, and I'll say do it in the original equation always, all right? Make it easy. Make sure you're going back to the beginning, the way they gave it to you. So I'm going to replace x with -8/9 back in the original equation and see if we get a true statement. See if it actually is a solution. So again, we said x is being replaced now with -8/9, and here we are going to check this. So we have 9 times x, but x is, -8/9, divided by 4. Right, just replacing x. And when you replace something, I would recommend putting parentheses around it just to make it easier on yourself. Plus 5/2. And is this equal to negative 1/2? Let's see if this is a true statement or not. Now, 9 times negative 8/9, the 9's would cancel. So we just have negative 8. Negative 8 divided by 4. Negative 8 in the numerator now divided by 4. Plus 5/2 equals negative 1/2. I still can't tell if this is true yet. Now, just to get the same denominator, instead of making this negative 2, I'm going to divide each one of these by 2. It's negative 4 over 2. Right? Negative 8 over 4 is the same thing as negative 4 divided by 2, right? They're both equal to negative 2. The only reason I did that was so the denominators are the same, right? We're adding here. When you add or subtract, you need the same denominator. And then you keep that denominator and add the numerators. Negative 4 plus 5 is 1. Oh, you know what I did? Okay, subtract. All right, because I'm getting 1/2 equals negative 1/2 here. So that means I made a mistake somewhere. Let's see. So I wrote the equation correctly. You subtracted 5/2. That's negative 6/2, or negative 6/2. See, I had negative 6/3 here. You're probably screaming at me the whole time, weren't you? So this is why you check your answers, folks. And hey, maybe I did this on purpose. I didn't. I actually made this mistake. I apologize. Look, I had negative 6 over 3. This should be negative 3, not negative 2. Negative 6/2 is negative 3. And that changes this to negative 3 over 1. Still have the 9/4 multiplied by 4/9. And then that'd be negative 12/9. Which, when you cancel common factors, these 12 and 9 have a common factor of 3. That'd be negative 4/3. This should be, all right, so that was bad, right? Negative 8/9 is bad, right? This was false. See, I got 1/2 equals negative 1/2. Oops, all right? That means I made a mistake. This is why you check your solutions, all right? Well, let's check the other one. Let's check this negative 4/3. So I apologize for all that. Let's check this. So 9 times negative 4/3 divided by 4 plus 5/2, is this equal to negative 1/2? All right, well, let's see. 3 goes into 9 3 times. This is negative 12 divided by 4. All right, this is negative 12/4 now. Plus, and then just get this to be fourths by multiplying by 2 over 2. That's 10/4, right? Just to get the same denominator. Is this equal to negative 1/2? Well, now that these have the same denominator of 4, keep that denominator. Add the numerators. Negative 12 plus 10 is negative 2. Is negative 2/4 equal to negative 1/2? Absolutely, right? This would reduce to negative 1/2. This equals negative 1/2. Yes, true. So this is a valid solution, right? The negative 8/9 I got earlier was bad. All right, that's a perfect example as to why you should check your solutions. All right, so now that I got it, negative 4/3 works. I'm going to go back and enter it. So again, I do apologize for the tiny error I made, but you see how tiny errors can lead to bad solutions, lead you down the wrong path. So then I went back and saw, oh, where's my mistake, and then fixed it. So negative 4/3, that worked. That worked. Okay, wonderful. And again, after every question, there should be it'll tell you if you're right or wrong, and then it'll give you an answer explanation. Please read through these, whether you're right or wrong. All right, if you're correct, read through it, make sure you got it right for the right reasons. All right, that you didn't just get lucky. Or, they may go through it in a different way that you like better, as something a way you didn't think about, and then you might want to try that in the future. Now, if you got it wrong, definitely read through the answer explanations, try to figure out where you went wrong, why you were wrong, and then fix that in the future. All right, so I'm going to stick with this question here. I want to show you another way to do this, all right, where you don't have to work with all the fractions all the time. So I'm going to write this equation again, but this time, and this method here is actually the way I prefer to do equations with fractions, and you probably will too. We'll see. But yeah, we had 9x divided by 4, and then plus 5 halves equals negative 1/2. So this is an alternate method. Which I really like, though. Alright, so I'm going to put some stars next to it. First, multiply both sides by the greatest, the greatest common, the least common multiple of the denominators, or the least common denominator, the LCD. You may have seen this. Multiply both sides by the least common denominator, or the least common multiple of the denominators. Again, just shortened to least common denominator, and it's going to be really shortened to LCD. Alright, so what's the smallest multiple of two, common multiple of 2 and 4? Well, the multiples of 2 are 2, 4, 6, 8, and the multiples of 4 are 4, 8, 12, 16, and so on. The smallest that they share is 4. Alright, here the LCD is 4. So I'm going to take the entire left side, I'm putting it in parentheses, right? There's the entire left side. The entire right side just has the one fraction, and we're multiplying each term by 4, right, by the LCD. Now on the left side there are 2 terms, so I have to do it to both, right? Distribute the 4. The right side there's just the 1 term. Now the whole reason for doing this is so all the denominators go away. This first step, if you have fractions, if you multiply both sides by the LCD, this should clear the denominators away. This clears denominators, clears fractions. Watch. So like 4 times 9x over 4. The 4's would cancel. Alright, I'm going to cover those up, and you'd be left with 9x. Plus, and then when you multiply 4 by 5 halves, I'll write it here, 4 times 5 halves, 2 goes into 4 twice, and you're left with 2 times 5 or 10. So the left side is 9x plus 10 now, after multiplying by 4. 9x plus 10. See, no more fractions, no more denominators. And then the other side, negative 1/2 times 4, 2 goes into 4 twice, that's just negative 2. And you see now, no more fractions, right? Fractions have been cleared. And then I do the same steps I did last time, all right? Where I would get the terms with x on the left here, and then I'll subtract 10 from both sides. Now I have 9x equals negative 12, and then get the variable x to have a coefficient of 1 by dividing by 9 or multiplying by 1/9. And then I'll cancel the 9's, and I'm left with x equals negative 12/9, which reduces to negative 4/3. All right, you divide the numerator and denominator by 3. And again, don't forget to check it, but we checked negative 4/3 already, it worked. All right, that was what I got back here. All right, that's what I entered, negative 4/3. All right. So if you like working with fractions, just leave it the way it is. If you don't like working with fractions, you're going to find the least common denominator, find the least common multiple of the denominators, and multiply everything by that, and that should clear all the fractions away. And you'll have a much cleaner looking equation. And then solve, and of course, like you saw earlier, check your solutions. As I made a mistake, you can make mistakes, it happens. But if you're checking your solutions, hopefully you'll catch those mistakes like I did. Alright, so moving on. The next question is on the same objective. Right, notice I'm now a quarter of the way through this one objective. Alright, so once again I'll write this out. Now this one has no fractions. Alright, so this should be a lot easier. Don't have to worry about finding the least common denominator and all this. Alright, so I'm going to write this out. We have negative 3 on the left side equals negative 8x plus 9. We're trying to find what value of x will make this a true statement. will give me negative 3 equals negative 3. Alright, so the term with x, that's the only term with x, is already on the right side, so I'll just keep it there and get rid of the 9 by subtracting 9, right? It's positive 9, subtract 9 from both sides. So negative 3 minus 9 on the left is negative 12 equals negative 8x, and then divide both sides by negative 8, right, to get the coefficient of x to be 1. Now remember, a negative divided by a negative is positive, and 12 divided by 8, those have a common factor of 4. Divide by 4, that's 3 halves. Positive 3 halves equals x. Let's check it. All right, so because I made that error in the first one, I might actually check the solutions for all these. Okay. So I'm going to go back to the original equation. All right, that one there. Replace x with 3 halves, or 1.5. So negative 3 equals negative 8 times 3 halves plus 9. Alright, now 2 goes into 8 4 times. This is negative 4 times 3, that's negative 12 plus 9. Is that equal to negative 3? Absolutely. We have negative 3 equals negative 3. It works. So 3 halves, 1.5, 1.5 is our good solution. So back here, x equals, just enter the number, right? The solution, 3 halves. Wonderful. And again, please, read through the answer explanations. All right. Now we're changing objectives. Solve equations in one variable. Right? So there's still only one variable to solve for, and that's probably going to be x most times. Variables on both sides, though. You see the 9x on the left and the negative 12x on the right. Well, that's easy enough to fix. Just, do some addition and subtraction, get all the terms with the variable to one side, and all the terms without the variable to the other side. So it's still the same steps. And then, of course, while you go through, simplify after each step, right? Combine like terms and junk like that. Simplify fractions. All right, so once again, I'm going to just write this equation they gave us out. We have 9x plus 8 equals 2 minus 9 minus 12x. Well, right away, 2 minus 9, those are constants. You can put those together. So I'm going to do that first. All right, we're going to simplify as we go. 2 minus 9 is negative 7. All right, and then you still have this term, negative 12x. All right, so now I'm going to, let's go to the left. I like putting my variable terms on the left. It doesn't matter really, just pick a side. So 9x, that term with the variable, is already on the left, but negative 12x is on the right. I want to get rid of that on the right side, so I'm going to add 12x. Right? I'm going to add 12x, to the other x term. We'll combine like terms. But then I'll still have this positive 8 on the left. I don't want that there, so I'm going to subtract 8 from both sides as well, and that'll go with the negative 7, right? And we'll simplify as we go. All right, so on the left side now, all right, 9x plus 12x, that's 21x. The 8's are gone, right? 8 minus 8. Here on the right side, the 12x's are gone. And you have negative 7 minus 8, that's negative 15. And then I'm dividing by 21 to get a coefficient of 1 on the x, right? So we have 1x on the left equals, now negative 15, this is negative, right? Negative divided by positive. And then 15 21sts, those both have a common factor of 3. If you divide each of these by 3, that'd be 5/7. And don't forget to check it. All right, don't forget to check it. All right, so I'm just going to say this out loud. Right, I'm not going to write it out, but negative 5/7. 9 times negative 5/7 would be negative 45/7. Plus 8, when you get a common denominator, would be 56/7. Negative 45/7 plus 56/7 would be 11/7. So I have 11/7 on the left side. Then 2 minus 9 is negative 7, which would be negative 49/7. And then negative 12 times negative 5/7 would be positive 60/7. And then negative 49/7 plus 60/7 is 11/7. You would have 11/7 on both sides. I'm sorry if that sounded a lot complicated, a lot of fractions there, but this does work. You'd end up with 11/7 equals 11/7. So negative 5/7 is a valid solution. And they got the x equals already, so I just need to put the number, negative 5/7. And submit. Great. Okay, but it's all the same steps, really. Get all the terms of the variable to one side, terms without the variable to the other side, and make sure you end up with a coefficient of 1 on your variable, and then of course check your solution back in the original equation. Make sure it works. Alright, so we're on the same objective again. Alright, this time we have some distributing to do. Alright, before I can move terms around, right? You know, think of the parentheses as walls that can't be budged. You know, we gotta clear them by using the distributive property. And then once I've used the distributive property, you know, the parentheses won't be there, and then I can easily move terms around with addition and subtraction. Alright, so let me write that equation out. So I have negative 2 times the quantity x minus 5, and then plus 6, right? This is all on the left side, equals. Here we have 4 minus 6 times the quantity x plus 5. Alright, so first I'm going to clear parentheses by, you know, because I can't move stuff outside the parentheses. You can't add or subtract and get rid of the things inside the parentheses, so I got to distribute. Now don't forget, you know, negative signs are part of terms. So I'm not distributing 2, I'm distributing negative 2 here. Same thing over on the right side. I'm not distributing 6, I'm distributing negative 6 to the x plus 5. Don't forget the minuses. Alright, so here we have negative 2x plus 10, right? Negative 2 times negative 5, and then you still got the plus 6. Alright, and we'll combine those in a second, make that 16. And over here we have 4, and then the next term would be negative 6x, and then negative 6 times positive 5 would be negative 30. And then just simplifying as we go, this is negative 2x plus 16 on the left. And over here I got negative 6x term, and then 4 minus 30 is negative 26. Okay. Now I'll do the addition and subtraction. You know, get all the terms with the variable on one side, terms without the variable on the other. I think it'd be easy to go to the left again. Just add 6x, get rid of the negative 6x, and do the same thing over here. And then I don't want the 16 then over here, minus 16 from both sides. Alright, so negative 2x plus 6x is 4x on the left. Negative 26 minus 16, that's more negative, that's negative 42 on the right. And then we're dividing both sides by 4, or multiplying by 1/4, same thing. And simplifying, right? So x equals, again, it's a negative divided by a positive, so it'll be negative. And they both have common factors of 2. If I divide each numerator and denominator by 2, there'll be 21 halves. And there you go. And again, check it. Alright, and just some quick mental checking. I see that it works. I know I did everything right, and I'm seeing that it works. Again, I'll leave most of the rest of the checking to you. Alright. But yeah, negative 21 halves, or negative 10.5, negative 10.5, however you want to write it, should work out. I'll go back here. Now they already have the x equals, so I just need to enter the number, the solution, negative 21 halves. And submit. Great. And again, please read through the answer explanations. Alright, now we're in this objective, right? New objective. Identify identity, conditional, and inconsistent equations. Now, the equations we've seen so far have been conditional. This would be called a conditional equation. Right, a conditional equation is true, true for only certain values of x. Right, like negative 21 halves. Right, that's a conditional equation. Right. Now, the other two types they mention, they have identities. An identity is something that's true for every value. True for all allowable values of the variable. So for example, if I had 2 times the quantity x minus 1 equals 2x minus 2, these expressions are exactly the same. Right? If I distributed the 2 here, this would be 2x minus 2 equals 2x minus 2. See how it's the same thing on both sides? So this would be true for all values of x. Right? True for all values of x. Has infinitely many solutions. Okay. That's an identity. Right? That's an example of an identity equation. Now the other type of equation they bring up is an inconsistent equation. Inconsistent. This is never true. Has no solutions. Never true. Has no solution. Right? This is like, the identity has infinitely many solutions. Everything is a solution. All real numbers are solutions. An inconsistent equation has no solution at all. And a quick example of this would be just like, x plus 1 equals x plus 2. This is never true, right? If I were to subtract x from both sides, this would lead me to 1 equals 2, right? If I subtracted x from... This is always false. Right, this equation has no solution. There's no number I could replace x with and make that true. There's a very simple example of an inconsistent equation. Right. Okay, so now we got the definitions out of the way. Let's look at the example they're giving us. All right, so the question they're giving us, the equation, is negative 4x minus 14 minus 9x on the left side equals negative 13x minus 7 minus 6. All right, so if I'll combine some like terms first here. You got negative 4x minus 9x. That'd be negative 13x. And then you got minus 14. All right, those are the terms on the left side. Right side, you have negative 13x, and then you have minus 13. You see, if I added 13x to both sides, look at what happens. You'd have negative 14 on the left equals negative 13 on the right. Eep. All right, that's a problem. This is always false. That means that this is an inconsistent equation. This equation has no solution. You couldn't replace x with any number and make this a true statement. It will always be false. So inconsistent equation, I mark off that choice, hit submit, and correct. And again, please read through the answer explanations. All right. Next question. All right, we're on the same objective. So again, you're just saying, is it always true? Only true for some values, right? Conditional, or never true at all, inconsistent. All right, so once again, I'll write this out. All right, so I'll just do it on the same paper here. So this equation, we have 6x minus 9 plus 8x on the left equals negative 2 minus 5 plus 9x on the right. Alright, so this is 14x minus 9 on the left when you combine like terms equals 9x minus 7. Alright, when you combine like terms. This is conditional. This is conditional, right? I would subtract 9x to get 5x on over here, I would add 9 to get 2 over here. We get x equals 2/5 after dividing by 5. All right, so this equation is true for only certain values of x. So this would be called a conditional equation, right? Like the first few examples we saw in this video. That's an example of a conditional equation. It's only true for certain values of the variable. It's only true for, when if x equals 2/5. And they run through here, right? Great. Next problem. All right, now we're switching to back to this objective. Solve equations where the variable's on one side, but this one is fractions. All right. I'm going to go through with that least common denominator method, where I multiply both sides by the least common denominator first. All right, so this equation looks like this. We have a -3/4 equals 3/4 times x, or 3x over 4, same thing, 3/4 times x, plus 11/8. We're asked to solve this equation. Again, with fractions, the first thing I'm going to find is the least common denominator, the LCD. Now 4, 4, and 8, the least common multiple would be 8. Right? So I'm going to multiply the left side by 8. I'm just going to write multiply everything by 8. Multiply each term on both sides by 8. -3/4 times 8, 4 goes into 8 twice. I have -3 times 2. The left side will be -6 when I multiply it by 8. Then again, 3/4 times 8. 3/4 times 8 is 6. So 3/4 x times 8 would be 6x. Plus, and then 11/8 times 8, the 8s would cancel and you have 11. All right, now the fractions are cleared. It's a lot easier to do now. Right? I would just need to subtract 11. All right, it gives me -17 on one side, 6x on the other, and then just divide by 6. And -17/6 is as reduced as that gets, equals x. And then again, don't forget to check your solution, which I'll leave to you from now on. Right? I feel like I learned my lesson from the first example. I'm doing these things properly now. So -17/6 should work. So back here, x equals -17/6, and this would be an example of one of those conditional equations, right? This equation is only true for certain values, this value here. Great. All right, again, please read through their answer explanations too, right? They may do things in different ways that you like better. All right, looks like we're still in this objective, another one with fractions. All right, so again, I'll write this out on paper, work on it, solve it. So -2/3 x, or 2x over 3, same thing, -7/3 equals -2. Now the least common denominator is clearly 3. That's the only denominator. And I'm going to multiply both sides, every single term, by 3. And that should clear the fractions. Now the 3's would cancel in the first term, leaving me with -2x. 3's would cancel in the second term, leaving me with -7. And then -2 times 3 would be -6 on the right side. Great, so then I add 7. You got -2x equals 1, right? -6 plus 7 is 1. Then I would divide by -2, so x equals -1/2. And check it, right? Don't forget to check it. Sorry if I'm going fast here, but the video is over 30 minutes long now. And I've done a couple examples of this crap already, so again, just check it, make sure it works out. But -1/2 should be the good solution here. So x equals -1/2. -1/2. Or -0.5, right? If you enter decimals, they should take them too, as long as the decimals are equivalent to the solution that you should get. Alright, so that objective's done. Now we're moving back to this identify conditional, inconsistent, or identity equations. Do you see how it would be 1 equals 1? I'm not even going to write this one out. If you combine like terms on the left, you get 1. On the right, you get 1. 1 equals 1. That's always true. no matter what you plug in for x. So this has infinitely many solutions. This is what they call an identity. Right? The left side and right side are the same thing all the time, no matter what you plug in for x. Identity. Alright, and then next. Alright, we're finishing off this objective. Alright, so I could probably do this right now. You got negative 11x minus 8 on the left side. On the right side, you have negative 11x minus 4. If I add 11x to both sides, you'd have negative 8 equals negative 4. That is always false. That is false. Negative 8 is not equal to negative 4. So no matter what you plug in for x, this will be a false statement. This has no solution. In other words, an inconsistent equation. Great. And again, please read through the answers. Alright, then I should just have that last objective to do, right? Just 2 more questions. Again, if you're getting things correct all the time, each objective usually is around 4 questions. Solve equations in one variable algebra, a variable on both sides. So again, I got some parentheses here to get rid of. No problem. All right, so I'll write this one out. All right, so on the left side, we have negative 5 times the quantity x minus 4. And then after that, plus 2 equals negative 1 plus, and then they have a set of parentheses here, x plus 6, but there's really no need for it because technically it's plus 1 times x plus 6, and when you distribute 1 it doesn't change anything, so really there's no need for the parentheses there. But over here I do have to distribute this negative 5. Alright, so we have negative 5x and then plus 20, and then you got the plus 2. Right, now don't distribute to the 2. The 2 is not in the parentheses. Right? Equals, and then over here negative 1 plus, and 1 times x plus 6 is just x plus 6, right? Again, there's no need for those parentheses over there. Combining some like terms, the left side would be negative 5x plus 22. The right side would be x plus 5, right? Negative 1 plus 6. Then I would subtract x, that gives me negative 6x on the left. Then I would subtract 22, gives me negative 17 on the right, right? 5 minus 22. Then dividing by negative 6, right? A negative divided by a negative would be positive, right? Positive 17/6, and those don't have any common factors, so that's as simple as that fraction gets. And again, don't forget to check your answer back in the original equation. Replace x with 17/6 and see that the left side number is exactly the same as the right side number, but I'm good. I'll leave that to you. So back here, x equals 17/6. Great. Alright, I should have just one more. Alright, so again, now this one, I'm just going to say it. Alright, you have negative 11x. You subtract the 10x, that's negative 21x equals negative 3. Divide by negative 21. Negative 3 divided by negative 21 would be positive 1/7. And you can check that solution if you wish, but positive 1/7. And again, please read through the answer explanations when you're done. And hey, you practice enough, you can get as good as I've just done here. I mean, you should, if you have enough practice with these things, most of them should be able to be done in your head pretty quickly. But, no harm in writing it out. Please write it out, especially the first time you're learning it. Write these things out. Get all the terms with the variable to one side, terms without the variable to the other side, combine like terms, then get the coefficient of the variable to be 1, and then of course check your solution back in the original equation when you're finished. Make sure that it's actually making it true. All right, and that should be it for this preview of this assignment. All right, and as I said at the top of the video, please understand that the questions I saw here might not be exactly the same as the questions you're going to see when you do the assignment, but the objectives are the same. It's got those same 3 objectives, so the questions should be similar. And I'm hoping that watching me do these here help you in some way, when you're working on the assignment yourself. And thank you very much for watching.